paper N4 was 29 March. Yeah, X paper. So the question that I want us to look into is question 1. Yeah, if you can do question 1.1, 1.2, I think we'll be done to cover determinants. So question 1.1, we're given equation xy minus 4 plus 2y equals to 0 and 3y equals to 4x plus 4. So therefore, we have to solve for the values of x and y by only using Cramer's rule. Only using Cramer's rule. So we know you can know how to use what is called elimination method, simultaneous equations, and the rest that you can mention. But here we're supposed to use Cramer's rule. So as we know that we need to always first arrange, let's say the first equation utilizing, let me arrange starting with x, y, and I want to take the constant to the right hand side. So I want to change this. This is going to be 2y, then is equals to, let's take 4 to the other side, it's going to be positive 4. Now let's look into the second equation. The second equation, you can either take 3y to the other side and take 4 to the other side, or bring variable x to the left hand side. It's going to be negative 4x. 3y is still positive, so it's still adding to negative 4x there. Then we have left 4 constant to the right hand side. It's going to be 4. Now what we're going to do, we have to deduce what we call delta or determinant. So the first column will come from the coefficients of x. So we're going to have 8 minus 4, 2, and 3. From there, our determinant is going to be equals to. We know according to simplification of second order, we say 8 times 3 diagonally down. So we do it in that way. So multiply diagonally down. So 8 times 3. So 8 times 3 is, so it is 24. Therefore, I'm going to say minus. Therefore, multiply diagonally up. So from minus 4 to 2. So we're going to get negative minus 8. Therefore, the solution is going to be equals to. So this is going to be positive 8. Then we add is 3. It's 30. 32. So therefore, our determinant it is equals to 32. Now we are going to solve for, let's start by solving for x. So if we want to solve for x, we need to find the determinant of x, or delta x. So therefore, we know that which element, okay, I will ask a question, which column are we going to replace here? The first column, right? So it came from the coefficients of x. So we replace by the constant. So by 4, so we are replacing by these constants, replacing these elements there, or that column. So we have 4, 4, and then the rest will remain the same because we're not solving for the other variables. So we only replace one column at a time. So we'll have 4 times 3, which is 12 minus 4 times 2. 4 times 2. So it is 8. Therefore, delta x it is equals to, delta x is equals to, it's equals to 4. That is delta x. Now we need to solve for x. We know that x it is equals to, so x is equals to delta x all divided by the determinant, or delta. Now delta x, we said it's 4, therefore our delta is 32. And 4 over 32 is 1 over, so it's 1 over 8. Or you can leave it in decimals. I'm not sure you're going to have 0.1 point something. So, but yeah, let's look into finding delta y. We need to solve for y. So finding delta y, we need to go and look into the original determinant. Please don't make a mistake of going to delta x. Going to the original determinant. Now we are going to replace the second column because it came from the coefficients of y. So the x variables remains the same, 8, -4. Then we are replacing by 4, 4. So we replace the second column from the constant, this constant here. Now we need to determine our delta y. So 8 times 4 is 32 minus -4 times 4 is minus 16. Pay attention to the signs, always the formula, it's minus. This came as a negative. Then the solution, we're having positive 16 plus 32 is going to be 40, 48. We're done. Now we can calculate y. So y is equals to delta y all divided by the delta. So delta y is 48 all divided by the delta is 32. Then the value of y is equals to, it's what? Fraction. It's, so it's 3 over 2. Or you can leave it in decimals and say it's gonna be 1.5. Yeah, so you can have 1.5. So that's how we're supposed to solve on it's for x and y using Cramer's rule. Using Cramer's rule. So I just want us to look into question 1.2. 1.2. 3 minutes. 1.2. So in fact, all in all, question 1.1, you had 6 months. It had 6 months. It had 6 marks. But always this will be a mark, even this will be a mark. Determining delta will be a mark. Let me look into this. This one I get the 6 mark. Finding delta. Delta is a mark, and finding delta x is a mark. And normally it's either how you have deduced, you can get 2 marks there or from the equation. So it's either you can get it here. So finding delta, say 2 marks, and finding delta x 1, finding finding x 1, finding delta y 1. Yeah, you can get your 6 marks like that. Easy peasy. So let's look into solving question 1.2. 1.2. So let's say we have 1.2 there. 1.2 was we're given, let me just say delta is equals to, we have 2, 3, 1, 4, 5, 3, -2, 6, 1. So 1.21, we need to calculate the value of the minor of 5. So we need to calculate the value of minor of 5. Let me just say minor of 5. So we need to determine the value of minor of 5. According to the formula of minor, I said always it's Mij, right? So let's look into 5. 5 is there. So it's in row what? 5. So when we check 1, it's in row 2. So that is 5. So it's in row 2. Therefore, it's in column what? So it's in column 2. So it's 1, 2. We're there. So it's in row 2. So it's M2, M2, 2. So the position is M2, 2. So normally you can be asked as determine M2, 2 or determine the minor of 5. So you need to know how to represent it in both forms. Therefore, as we're saying we're in looking for minor of 5. So eliminate horizontally and vertically from element 5. Therefore, the minor of that element will be equals to, so it's 2, 1, and minus 2, and 1. So that is the minor of element 5. And then from there, we can evaluate the second order determinant now. This is second order. So we're going to say 2 times 1 is 2, therefore minus 1 times negative 2. So we're going to have minus 2. The solution is going to be equals to positive 4. So that is then minor of 5. And then get your 1 mark there. So let's look into question 1.22. So we need to determine or calculate, we need to calculate the value of the cofactor of 4. Calculate the value of the cofactor of 4. So the value of cofactor of 4. So cofactor, we know we can use small letter a or capital A. So 4 is in row what? 4, element 4. So in row 1 column, it's in column 2. So that's what you see. So A1, 2. Now, we're going to say minus 1 to the power of I plus j. So it must be I plus j, so it's 1 plus 2. So the row number plus the column number. So 1 plus 2. Therefore, multiply by the minor of element 4. So when a 4 there, we eliminate vertically and horizontally from element 4. The remaining element is 3, 1, 6, and 1. That is the minor of 4. Therefore, simplifying, we're going to have the solution is going to be equals to, so negative 1 to the power of an odd number, which is 3, it's going to be negative 1. And I'm going to say 3 times 1, so it's 3 minus 1 times 6. So we have 6. The solution is going to be equals to, let's solve everything at once. So this is going to be negative 3 times the negative 1. It's going to be positive 3. So that is the cofactor of 4. Cofactor of 4. So you mark there, determining and deducing the element there. Deducing what is it? The cofactor. Easy peasy, lemon squeezy. So that's how we solve for what do you call the cofactor and solving for x and y in question